Last time, we explored wireless redstone for the very first time. We discovered its powers, but also its weaknesses. Today, we continue the mission to create stable, reliable, and fast wireless redstone. Welcome back everyone, I'm the Redstone Warper here. In this video, I'm going to be showing you the development that I've made since my previous video, as well as going into a much better explanation of how this wireless redstone system works and what causes the false detections to trigger and how I solved them. If none of that made sense to you, you should probably watch my previous video on wireless redstone. I will also be explaining why it works differently in multiplayer versus single player, and there will be timecodes in the description as well as in the play bar so you can skip right to the part that you need. As always, before I get too far into the video, go ahead and leave a like on the video and maybe even subscribe and ring the bell to see when I post next, and join the other 105 people who already did. To those people who already subscribed, thank you so much for supporting my channel. It really means a lot to me to see so many people enjoying my videos. Since we just passed 100 subscribers, I've also opened up a Discord server that I promised, and you can find that in the description below. Before I go over the new designs that I created, this is the older design here, which I used this system here to cancel out false signals, as well as this double sender here to send the signals that wouldn't get blocked by this signal limiter here. If we go ahead and just turn this machine on, come over here and activate the sender, you can see that it will detect the pulse and get sent out here to this teleportation machine, which I had hooked up to this initial prototype. The biggest issue with this particular machine that I attempted to solve first is that if I were to disconnect and reconnect, this device would no longer be in sync and it would no longer be able to receive signals from this transmitter over here. This can be very irritating if you're loading and unloading chunks, and so I decided, what if there was a way to sync it when the chunk's loaded instead of waiting for the daylight to change to night. So if we skip past some failed prototypes over here, you can see that I added this system right here. I ripped out the original clock update cycle over here, and I added in this one instead. Using a similar design that I used for the actual transmitters themselves, I make it so that when this block is pushed above this daylight sensor, it sends out a signal, which then gets turned into a 1-tick pulse, and sends back into the clock, just like the other design would. Except this design can be triggered whenever you want using this vent gate right here to reset the clock cycle. To demonstrate that, I'll turn on the machine, which probably won't work because this design has a flaw in that it does not update on load. So this does not work. But if we turn on this trapdoor, that activates the daylight detector thingamajig, and we press the button now it will receive the signal just like that. But this design is actually missing something that the original had, in that it would automatically sync itself when you started it and you didn't have to manually do anything in order for it to sync. And so for that, I came over here and just changed up the circuitry over here. We don't need the piston to update the daylight sensor anymore, and we just wire it into this observer so that it actually triggers the update system right when we start it. So if we enable the machine, and make sure that this one is off because they interfere with each other, because I believe they are on the same signal. As you can see, the constant interference there. We can now use this transmitter here, and it was synced automatically without us having to do anything manually. But this still doesn't have the feature that I really was attempting to have, in that it would auto-update on load. And that is why I built this Armor Stand Frostwalker load detector. What happens is every time you load the game, this will create frosted ice here, which is detected by this observer, which then gets sent around here to trigger only once, so that this piston can pull down the ice, breaking it so that we only get one output instead of 5 consecutive outputs as the ice melts, and then that gets sent into the original updater device that I created here, so that no matter if this is running and you load it, or whether you just turned it on, it will sync. To show this, we can enable the machine, and we can come over here and transmit. Oops, wrong button. We can transmit and get an output, And if I just quickly save and quit, go back into the game, you can see that this machine triggered, which will resync it. Obviously, we get some error outputs at the beginning, which I still need to fix. And we can now transmit our signal once again, now that it has been synced after being loaded for the very first time, instead of breaking every time you unload it. Now that I got that working, I decided to make a fully functioning teleport system as compact as I could, which is this footprint right here, which is still rather large, and I do plan on redesigning to try to make this as small as possible. The way this works is just like the other one over there, is that instead of just detecting our signal, we send it into this device over here, which is an improvised player detector. What happens is, if you didn't know, you can use cats on top of chests to detect when their owner has logged out. So currently, the comparator here is detecting a signal, meaning that yes, I am logged into the system, but it will only change its output when we can update it. So for that, I use this honey block to actually push the cat further into the chest area here so that it gets updated, so that we can detect if I'm online when this is triggered. To test this, I just set up these two command blocks. So here I'm simulating me joining the game. So I am in the game according to this system. And so now we can transmit our signal and get our output. And that would have teleported me had there been an ender pearl. To simulate me leaving the server here, which I just do by changing the cat's owner to be somebody else, and then just printing that message in chat for demonstration purposes. Now that I have left the server, we can push this button here to transmit the teleport code, and as you can see, it will actually get blocked because this will stop detecting the item because I am not online, and it presses the cat down, blocking the signal, stopping the trigger from accidentally being triggered. This is useful so that if you're not online or in the wrong dimension, so that you can't accidentally waste your ender pearl, leaving you no way to get back to the machine in a timely fashion. So if we just join the server, quote unquote, again, and transmit, it will now detect that I am in the correct dimension and teleport me. The next machine that I created here is this transceiver pair here. So the sender of this one corresponds to the receiver of that one, and vice versa. What this system does is this light will turn on when it has confirmed that the signal was sent to the other side. So if we transmit here, you can see that the signal is sent over to this machine, which then turns this lamp back on and resets the machine. This way we can send a signal and have the sender know that the message was received, and both of these are stateless so that you can use the same design for both sides, which makes it nice and easy to create systems of these. The next step for this system would be to, after a certain period of time, if the signal was not received, it could send the signal again to try to continue to get through to the receiver in order to get the message across. Now that I have shown you the newer models, which I do plan to redesign to make them smaller and more compact and hopefully faster, a lot of people were asking how this works, and to be completely honest, it's very complicated. Make that extremely complicated. But I'm going to do my best to explain it as simply as possible, so I'm going to give it in 3 levels of explanation: easy, moderate, and advanced. So, as simply as possible, the way this wireless redstone works is magic. That's all there is to it. No, of course I'm kidding. Although it would definitely seem to magic to anyone who has never seen this before and has no idea how it works. The simplest way to explain it is that 2 items at the back here get dispensed at just barely offset from each other, so that when another item is created at the same time by the receiver, the discrepancy between when the 2 hoppers process their output will actually create an output, making the detection possible. This happens because hoppers process their entities differently at a different speed depending on when the entity was created, that I will go into more in just a minute. Now, before I get to the advanced part, be warned that this is going to get very technical. So if you would like to skip this part, there are time codes in the play bar as well as in the description if you want to skip ahead to the next section. To understand this form of wireless redstone, we need to understand how the game processes redstone, more particularly redstone repeaters and redstone comparators. The way repeaters work is that they take an input from the back, and based on a set delay will schedule an update for themselves accordingly. So a repeater set to 3 redstone ticks or 6 game ticks will be scheduled to update after 6 game ticks have passed before updating, instead of looking to every game tick to see if they have been powered. This reduces a ridiculous amount of lag that would be caused, and is crucial to how this form of wireless redstone works. Now that we understand how repeaters and comparators update, it's important to note that repeaters get processed before comparators do in the update order. This is what makes zero-tick generators possible, as well as a key component to how this machine works. Just for an example, this is a simple zero-tick generator which uses the fact that the repeater updates before the comparator in order to create a zero-tick, which causes this piston to extend and retract in the same game tick. So if we look at this redstone receiver over here, we can see that there are 2 repeater lines set to the same timings, except one side has a repeater and one side has a comparator. And of course, these repeater and this comparator cancel out with this 2-tick repeater. Because of repeater comparator update order, this line with the repeater will actually update first, followed by the one with the comparator. This all happens in the same game tick, but at a deeper level, the dropper connected to the repeater only line dispenses first inside of the game tick, before the one with the comparator line dispenses. This happens because single-threaded programs like Minecraft, excluding the light thread, can only do one thing at a time. So each event happening in a game tick happens in a particular order. So now that we understand how repeaters and comparators update, and how the repeater will update first, causing the droppers at the end to spit out their items in a known order, one of the last crucial concepts to understand is how entities, in this case items, are created and processed. In Minecraft, when an item is created, it gets its own global entity ID. This basically uniquely identifies each item to when it was created, so we know that an item of ID 2 was made before an entity with ID 5. So we know that this first diamond over here was created before this one, because this entity ID will be lower than this one over here. And this entity ID is global, which means it increases every single time an item is created into the game. Now, Minecraft can be a very laggy game, so Mojang coded it so that not all items in the game will try to move at the exact same time, because this could be very laggy if a lot of items are created at the same time. So it was made so that based on the entity ID, they will get processed in batches. So in one game tick, some of the items will get processed, and then another set will get processed based on their entity ID. Because entities with 2 different IDs may get processed at 2 different times, we can detect the discrepancy between when the items are processed by a hopper. Now that we kind of have an understanding of all these things, we can now understand how the system itself works. So, because these lines here dispense the items in a known order, what happens is this item over here gets dispensed first, and this second dropper will also dispense an item just barely after it. The way that we actually trigger the system is by summoning in an item at the same time as the item in this dropper over here. What this does is cause the dropper over here's item to have a higher entity ID, which will then cause it to be processed 1 tick later than the item over here. And because the items are now processed at 2 different times rather than at the same time like normal, it will then generate an output, turning on this lamp. As you may have noticed, the droppers up here are also dispensing items, and this is to increment the global entity ID count so that the system can continue to detect items every single clock cycle. If the item ID of the detector item is such that it gets processed later than the other detector item, there will be a signal detected. This happens because the transmitter causes an item to be created at the same time, which increments the global ID so that there is a detectable difference between the hoppers over here picking their items up, because this item over here will have a much higher entity ID compared to the one next to it, as it normally would be. Now that we understand why we can detect the difference between items spawned at the same game tick with different entity IDs, we need to figure out how they actually are summoned in the same exact game tick, as randomly dropping an item will almost always be at a different game tick than a receiver. So we need to effectively sync two clocks over an infinite distance, and for that, we use the daylight sensor. Because the daylight sensor gives an update every few minutes at a fixed time interval with the passing of the day-night cycle, we can use this to make it so that the receivers and the senders are dispensing an item in the same game tick. This works because daylight sensors do not update like other components and will only update itself with the day-night cycle. This is especially apparent because if I place this down, you can see that there is a noticeable delay between when I place this down and when this repeater updates, unlike if I were to take a lever, in which case the repeaters will update right away. So because daylight sensors create an update at a fixed time, and if we actually separate the updates by a slight amount of time, if we just do this here, we can see that these lines actually get triggered at the same time despite this being detected afterwards. So because we're using a daylight sensor under here to sync the original clock at the detector, and we use a daylight sensor to actually transmit the signal so that the updates are processed at the same time, we can effectively sync when these sets of items are dispensed so that we can actually detect our wireless redstone signal. Now, as I have mentioned before, this current system can have over 4,000 channels or frequencies. This again goes back to the way repeaters schedule their updates. So, 2 repeaters, like this, at 2 ticks, and 1 repeater at 4 ticks do not actually happen at the same time because of the way that the repeaters are scheduling their updates. In this way, different combinations of repeater lines will create different frequencies or channels that you can transmit items on and detect. So changing the pattern of these repeaters, we can cause the exact timing of when the item was dispensed to be different, so that the timing between different machines is different, so that we can have multiple of these systems running on different frequencies without interfering. This is also why it is so hard to accidentally trigger the system by randomly spawning in items, because you have to get the timing exact. Not game tick exact, like in between the game tick exact. You made it through the detailed explanation. Thank you, as it took me a very long time to formulate this description on how it works. So if you think I did a good job, or if there's ways I could still improve it, please feel free to leave a comment below. Now, just because we can't trigger the system on accident by spawning in random items at random times does not mean it's without errors. Unfortunately, chunk generation can create a false trigger in both systems, in multiplayer and single player. Although in single player, you also have to worry about items coming into render distance can also cause a false trigger because the client can update the global entity ID instead of just the server. The way I fix this is by actually summoning 2 items here, which you've seen in every transmitter design that I've made, so that it creates a longer pulse than just your normal output. So if we just extend this over here, and we enable this machine, assuming that I didn't leave any of them on, which it looks like I didn't. So to demonstrate this, when you actually send a signal over here, you can see that the first part of the signal gets cut off by this system here, but the rest of it is allowed to pass through. To simulate an error real quick, which sometimes you can get by just kind of loading some chunks in different directions in single player, it's really quite random on when it happens. But if we just simulate this by using one of these lines, instead of both of them like the design requires, you can see that the system here is detecting a signal, but it gets cut off and does not allow it to pass through the system because it requires a longer pulse in order to be able to trigger the system. That way, no matter what interference is created, it will always get blocked when it's interference, and it will always pass through if it's not. Another idea that I had on how to cancel out the errors was to actually use another one, which right here I just had flipped this one sideways to try to see if they would pick up the same interference, which they do. But here what I discovered is that if we use one of these with a faster clock that happens just slightly before this other one does, we can detect all of the errors that happen to this one when we're not transmitting anything to this one.
That way they will both light up if it's an error, but only this one will light up if it is actually a signal. And so in this way we can detect an error, and only an error, and then use that to block the signal here. Well, I think that's about all I have for you guys today, so thanks for watching. And for all of you who made it all the way to the end, here is a sneak preview of the super smelter I've been designing, which the video will be coming out next. The first person to guess correctly how many furnaces are in this array will be pinned, and will be featured in the next video.